convolution, we can see a purple layer, and that is the salt range layer, which is, if you remember, is the layer with the salt in it that is creating the ductile flow. And so what we're seeing is that due to the bulldozing effect of the main boundary thrust, we have all this complex convoluted thrust belts and a series of thrust faults. And indeed, in the salt range area, the thrusting is so extreme that the unit has thrust 30 kilometers over itself because the Ducomet process was so effective. And here's a slightly more naturalized view of the same thing. So now we reach the synthesis portion of the presentation. Well, let's think about what we have. For starters, we have the Potwar area, which is completely bounded by faults, which is very unique, and seems to be particularly affected by the effects of the main boundary thrust. We know that this was formed by the collision of the Indian Eurasian plate, and it continues to function off of that today. And we also know that the Ducomet process is very active in the Potwar, the faults in the Potwar are created by the Ducomet process. As the main boundary thrust acts on the Potwar plateau, it pushes it and acts upon it far more than other sections along the Himalayan main boundary thrust, and so creates a far more extreme and unique structural geology. So in order to kind of illustrate the synthesis, I came up with something called the Great Paper Towel Experiment. And I have a video of it, and it just kind of illustrates, from my perspective, what I see going on in the Potwar in a very active way. Sorry, technical difficulties. Where is the video? Alright, seems like it shut down. Hold on a second, folks. It's coming. Just takes a second. So I want to open this file. Important value of presentations, always have your stuff ready beforehand. Okay, so here it is. Here's the video. I'm going to make it full screen so everybody can see. And I'll rewind it here a little bit. It kind of got ahead of me. So yeah. Before I start the video, I just want to explain some things real quick. So this arrow here represents the main boundary thrust and its effects on the Potwar plateau. And just FYI, this has been flipped upside down. This would be north, this is south, east and west. And so these perforations illustrate where the salt range layer laterally pinches out. And this central area just represents the Potwar plateau as it's illustrated. So I'm going to run the video, and I'll let you see what happens. I'm going to let it run again here, and I'll pause it. Alright, so what we're seeing here is that as the main boundary thrust pushes forward on the plateau slides forward far more and far faster than any of the surrounding rocks because it is, essentially lubricated underneath by the salt layer. These areas here represent, on the other side of the perforations, represent the rocks that don't have, as we talked about before, they don't have the Ducomet process happening, and so they stay in place more than the Potwar plateau rocks do. And as the Potwar plateau is pushed forward by the main boundary thrust, the rocks can't deform quickly enough to accommodate the movement of the Potwar plateau, and so the strike-slip faults on the eastern and western borders of the Potwar are formed. And as we can see, as the main boundary thrust acts on the Potwar plateau itself, it's pushing it forward so quickly that all the brittle layers duplex up on top of each other into these complex folds. And it is these complex folds that help make the Potwar plateau so much more valuable, as I will demonstrate in my next slide. Hold on a second, let me get out of the video. Alright. So back to the slideshow. We just said that oh shoot. Get back to where I was. Alright, we are in business. Okay, So now that we've gone through all of these different portions, we can come back to our original question of what makes salt as valuable as gold. And the answer is oil. Because of the complex folding, as I demonstrated with the great paper towel experiment, we get all of these great, essentially, hydrocarbon traps. The thrust and duplexes are excellent for trapping hydrocarbons, and here we have innumerable versions and portions of the Potwar Plateau that are dedicated to basically just these complex duplexes. There are many Silurian source rocks located beneath the Potwar Plateau, and because of its complex structural geology, it's able to trap the hydrocarbons, whereas other areas along the Himalayan front are not able to do so. So basically, the Potwar Décollement creates complex hydrocarbon traps, which in turn makes it a very economically valuable area. So our conclusions are the Potwar is defined by the 4 faults that surround it, the 2 strike slip faults, and the main boundary thrust and the salt range thrust, The structural and stratigraphic influences that created the Potwar were the collision of India with Eurasia and the continued effect of the main boundary thrust on the Potwar Plateau, which is gliding forward on salt faster than the rock surrounding it can accommodate. The strike-slip faults are formed by this lack of accommodation from the surrounding rocks, so they rupture and create 2 strike-slip faults so that the Potwar Plateau can continue to move forward unhindered. And it all works together to create an amazing oil field that is so very complex and quite excellently structured that it continues to be productive to this day. And so we can conclude, therefore, that the Potwar Plateau will probably continue to be successful, as we can imagine the depth to which it is folded and faulted. And by